Hello friends, you are all welcome to this video. In the previous video, we studied the surface area of a cuboid. Today, in this video, we shall study about the surface area of a cube. Manas and Thomas are playing a game of snakes and ladders.
Thomas, it's your turn. Why are you taking so long? Throw the dice quickly.
Wait, Manas. Did you notice that this dice is not cuboid in shape?
Yes, Thomas. All the faces of this dice are square. So the shape of this dice is that of a cube. That means its length, width and height are exactly the same.
So, if we had to cover this dice with paper, how much paper would we need?
This is a math question. That means it's math time! Suppose the length of each side of this dice is 1. If we open this cube-shaped dice and flatten it, its shape of a net will be formed and it will look something like this. Can you tell me what will be the area of each side of the dice?
Each side of a cube-shaped dice is square in shape. Therefore, its area will be L times L or L squared. Hey, wow! So if we add the areas of all these faces, then we will know how much paper will be required to cover it completely. But the sum of all the faces of this cubic dice will be equal to its total surface area, right?
And look, Thomas, all these faces are exactly the same. Therefore, the total surface area of the cube will be 6 times the square of L, where L is the length of each side of the cube.
Wow, Manas! We found the formula for the total surface area of a cube. Now, let us quickly measure the length of the side of this dice and write it in this formula. Then we will know the total surface area of this cube.
The length of the side of this dice is 1.5 centimeters. In this way, the total surface area of this cubic dice is 13.5 square centimeters. This means we will need 13.5 square centimeters of paper to cover this dice completely.
And Manas, what if we have to cover only the standing or vertical surfaces of the dice? The sum of the areas of all the sides that are left behind after you remove the bottom and the top faces of any cube is called the lateral surface area of that cube. This means that the lateral surface area of a cube with sides of length L will be equal to the sum of the areas of these square sides. But all these square sides are congruent. So, we can write it in this way as well. Hey Manas, we also found the formula for the lateral surface area of a cube.
Let me write the length of the sides of my dice, that is 1.5 centimeters in the formula. Look, Thomas, this cube-shaped dice has a lateral surface area of 9 square centimeters. This means we will need 9 square centimeters of paper to cover the lateral sides of this dice.
Wow! Today we learned 2 more new formulae. Let me quickly write them down in my math formula book.
Now let us return and complete our game today. I will definitely defeat you.
Both the friends started playing their game again with great pleasure and enthusiasm. In this video today, we studied the surface area of a cube. In the next video, we shall see some interesting examples based on this. Hello friends, we welcome you all to this video. In the previous video, we studied the surface area of a cube. Today, in this video, we shall see some interesting examples based on that.
Manas, what are you doing?
Dad has made this new stool for me. I am thinking of painting it. But I can't figure out how many boxes of paint will I need to paint it.
Aha! We can find the solution through mathematics. Do you know what it means?
Absolutely! That means it's math time!
Manas, this tool is cube-shaped. Can you tell me how many square feet can you paint with one color box?
The shopkeeper told me that with one paint box, we can paint an area of 4 square feet.
To find out how many boxes of paint you will need to paint this tool, first we need to find the sum of the areas of all the surfaces of this tool.
But the sum of all the surfaces of this cubic stool will be equal to its total surface area, right?
Absolutely right. Therefore, we will find the total surface area of this cubic stool.
Thomas, this stool is cubic. And we wrote this formula for the total surface area of a cube in the formula book of mathematics, where L is the length of the sides of the cube. Now, we just have to write the length of the side of the stool in this formula and we will get its total surface area.
Friends, if the length of each side of the stool is 2 feet, can you find the total surface area of this tool? Pause this video to try it yourself and then come back and match your answer.
The length of each side of the stool is 2 feet. Let me write it here instead of L. Okay, the total surface area of the stool is equal to 24 square feet.
Now, with one box of paint, we can paint an area of 4 square feet. So, if we have to paint the total surface area of the stool, that is 24 square feet, how many boxes of paint will we need? So, we have to divide the total surface area of the stool by 4.
Look, Thomas, I got it. 6 boxes of paint are needed to paint the stool. But Thomas, we have only 4 boxes of paint. So what shall we do now?
Don't panic, Manas. Let us paint only the vertical surfaces of this tool. Maybe we can paint these surfaces by using these 4 boxes of paint.
But Thomas, the vertical surfaces of this cubic stool indicate its lateral surface, isn't it? This means that the sum of the areas of these surfaces will be equal to the lateral surface area of this cubical stool.
Friends, can you help Manas find the lateral surface area of this tool? Pause the video to try getting the answer yourself and then match your answer. do you remember the formula for the lateral surface area of the cube that you learned in the previous video? Let us write 2 feet as the length of the side of the stool instead of L here to find the lateral surface area of the stool. In this way, the lateral surface area of the stool is 16 square feet. With one box, we can paint an area of 4 square feet. So, in order to paint the lateral surface area of the stool, that is 16 square feet, we would need 16 divided by 4, that is 4 boxes of paint.
Look, Manas, you can paint the lateral surfaces of the stool with your 4 paint boxes. Let us return back and paint your stool quickly. Then we have to also go to play.
Both the friends painted the lateral sides of the stool beautifully. In this example, we have seen how we can use the method of finding surface area of the cube in order to solve some problems in our daily lives. In the next video, we shall see some fun concepts based on this. You are all welcome to this video. In the previous video, we solved an example based on the surface area of the cube. Today, in this video, we will see some fun concepts based on it.
Thomas, you have decorated this box with such beautiful paper.
Yes, I first found the lateral surface area of this cubic box and then I cut the paper of that area and decorated the box.
Friends, if the length of the side of Thomas's box is 12 centimeters, can you find the lateral surface area of this box? You may pause the video to try it yourself and then match your answer. Oh wow guys, your answer is absolutely correct. The lateral surface area of Thomas's cubic box is 4 times the square of the length, 4 times the square of 12, meaning 576 square centimeters.
Thomas, do you know that instead of covering the specific sides of the box, we can also decorate it by changing the orientation of the box and use the same paper. And we won't even need more paper.
How is that possible?
Let me explain this to you through mathematics. It's math time! Look, Thomas, right now the orientation of your box is like this. If I rotate it like this, the orientation of your box has changed. Don't you agree?
Yes.
Now, can you find the lateral surface area of this cubic box?
Yes, of course. All these faces are square and also congruent. This means that even in this orientation, the lateral surface area of the box will be 4L square, where L is the length of the sides of the box. And the sides of the box are 12 centimeters in length. This means that even in this orientation of the box, its lateral surface area will still be exactly 576 square centimeters.
Now do you believe me, Thomas?
Yes, Manas. Now I get your point that the lateral surface area of the cube remains exactly the same even if its orientation changes.
Better late than never. Now let us return to our world.
In order to explain it better to him, Thomas decided to gift that box to Manas. Friends, in this video, we saw a fun concept based on the surface area of a cube. So hopefully you will have a good understanding about the surface area of a cube.